So to start this off, and for the people who might be at home who decide not to join on the Zoom today, the first part of this is going to be pretty easy for you. Well, maybe not. I don't know. We'll have to wait and see. I'm not going to draw too much. Now, since we did have an interruption in class today, we're not going to spend as much time as I was normally going to do. But what I want you to do, and you can do this in pairs if you want to, I need you to get together and very quickly, and both of you need to do this, not just one person, on a blank sheet of paper. You know where blank paper is. I have some up front and some in the back. On a blank sheet of paper, I want you to write down all of the things that you remember about motion graphs. Write down all the things that you remember about motion graphs, the different types of motion graphs, the misconceptions about motion graphs. Can you pull out that old study guide that we made way back when? Yes, if you want to get that out, you can use your notes that we used on this that we made back in the day. It's been a long time, but you can get that back out if you still have it. If you don't have it in your notes, then you might need to get this into your notes. But if you're at home and you're watching this on YouTube, if you're in class, we're going to spend about the next maybe 10 minutes with our partner, sitting around the room quietly without going crazy, writing as much as we can remember, and when we get back in our seats, we'll put this back up on the board. So I will pause this. Obviously, you'll need to pause the YouTube video. Otherwise, you'll be jumping right into the next part of the lesson. All right, so now we're back from our break where we've taken some time to think about some things about motion graphs. And I think the first thing that I realized as I went around the room, I think everyone remembered that there are two different kinds of motion graphs. We have distance, time, and speed time graphs. Okay, and our distance time graph and our speed time graph look extremely similar, except one thing that we're going to remember, Brianna, when we are taking the test on Friday and when you do the quiz today, you're going to first look over here on this axis, which is which axis? The y-axis, to see what type of graph it is. Is it a speed time graph? Is it a distance time graph, Malachi? Because that's very important, isn't it? Because, Nicola, if I look at these two graphs, they look exactly the same, Brianna. They look exactly the same, don't they? Would you agree, Brianna? Those two graphs look exactly the same? But they mean completely different things. And if you have to put some numbers in here for it to make sense to you, that's fine. Notice 10, 20, 30, 40, 0, 1, 2, 4. Now, if I look at this graph, I need to notice something. Victoria, what is this graph telling me? Yes, even if this is like 1 minute. At 1 minute, the object is at 30. 2 minutes, the object is at 30. 3 minutes, the object is at 30. 4 minutes, the object is still at 30. It's not moving, is it? And we have that very special word that we learned this year, that this is called at rest. Now I look over here, Carter, at this exact same looking graph. Because it looks very similar, right, Carter? Looks exactly the same. But I notice at 1 minute, it's going 30 miles an hour. 2 minutes, it's going 30 miles an hour. 3 minutes, it's going 30 miles an hour. 4 minutes, Ruby, it's going 30 miles an hour. If you're going 30 miles an hour, you are most definitely not at rest. What would we label this graph? Brianna? This is a constant speed. A constant speed. So we see these two different graphs. Give me a thumbs up if you remember some of this. Some of the rust is being shaken off of our brain today. I remember some of that. Now, let's take a look at, well, I guess, what's the misconception that some people have about this? What's something that people say about this graph that they might get confused on? Cruz. Nope. Some people think, so I'm going to put, this is not a flat road. Okay, they could be sitting still on a flat road. They could be, Cruz, going 30 miles an hour on a flat road, but I don't know that. This has nothing to do with the shape of the road, whether it's inclined, declined, or flat. So do remember that. So we have some others that we need to look at. So we have our, whoa, that going red. I'm just going to abbreviate distance time and speed time. Except this time, it looks like this. Very, very common thing for us to see inside of graphs. Now, Tori, if we need to, we can put when I see this type of graph, Haley, obviously the first thing I'm going to do, what kind of graph is it? Is it a speed time graph? Is it a distance time graph? And now, so over here's distance and this one's speed. So when I see a distance time graph like this, what do I remember about that? Yes. It is increasing, but what else do we know about it? We call this a very specific type of graph. This thing is doing something very in particular. Is it? Let's find out if it's accelerating. So at 1, it's going 10, 2, it's going 20, 3, it's going 30, 4, it's going 40. So if I look at that, so after 1 minute, it went 10 miles. After 2 minutes, it went 20 miles. After 3 minutes, it went 30 miles. After 4 minutes, it went 40 miles. If I do my, which is the next thing we're about to review, distance, speed, and time, right? Speed equals distance divided by time, right? So 10 divided by 1 is 10 divided by 1 is 10. 20 divided by 2 is 10. 30 divided by 3 is, and 40 divided by 4 is. So every time I check on this car, it's going 10 miles an hour. What would we call that? Every time it's 10 miles an hour. This is a constant speed. But Mr. Bullen, you just said a second ago that this is constant speed. Yes, this is constant speed on a speed graph. This is constant speed on a distance time graph. Big difference. So I look over here, Mason, at this speed time graph. I know it can't be constant speed. It's going something, so it's definitely not sitting still, so it's not at rest. How would I label that? At 1 minute, it's going 10 miles an hour. 2 minutes, it's going 20 miles an hour. 3 minutes, it's going 30. 4 minutes, it's going 40. 5, it's going 50. How would I describe that, Mason? What's happening to the speed on here? Every time I check, it's going what? What do we call that? This is an acceleration. Now, there's a huge misconception that people have about this. What is this not? This is not showing a car doing what, Maya? This is not going up a hill. Again, do not confuse this with the shape of the road. Not a flat road, not going up a hill. Not going up a hill. You've got to be very careful with that. What's our first two? Abbreviating even more this time. Distance times speed time. Let's knock the easy part out. Haley, what is this not? Not going downhill. Let's take a look at our speed time graph, Miguel. When we first started out, we were going 40 miles an hour. About a minute later, we checked it. We were going 30, and then we were going 20, then we were going 10, and then we were going 0. What's happening to the speed of that car? 40, 30, 20, 10, 0. What's that fancy word for slowing down? It's the opposite of acceleration. Thank you, Miguel. Deceleration. Deceleration. You're slowing down. Okay? Not going down a hill. You're decelerating. What's happening over here on this distance time graph? That's very easy to mess up. We mess it up so much until we actually plotted it out. What are we doing on this one, Nicola? Going back to the origin. We're going back to the origin. You are not going down a hill. You are not slowing down. You are going back to the origin. Now, Brianna, does that make sense to you? You remember doing that one? Like you would go somewhere and go back. So I know later on you might see one that looks like this. That's not going up a hill, not going down a hill. That's somebody walking to the store and then walking back home. And there's no stopping involved in there because we don't have any of the at-rest portions in there. A little bit of dust knocked off everybody's brains. Everybody feeling good about that?